Thank you, Stephanie. Really appreciate that everybody's taking time out during Child Passenger Safety Week. Happy Child Passenger Safety Week to all of you, and thank you for all the excellent work that you're doing to educate and empower families. I'm Joe Colella. I am a child passenger safety advocate and have been for 30 years, actually 30 years this week. In my professional roles, I am the Director of Child Passenger Safety for the Juvenile Products Manufacturers Association. So I work with a lot of the car seat manufacturers in that role. And I'm also a contractor for Safe Kids Worldwide and help with the advocate side of things there. I should mention, as a certified child technician instructor, and in the roles that I just mentioned, I want to be clear that I cannot and do not endorse a particular manufacturer or a car seat. I am, however, quite familiar with the products that are on the market right now, along with those that have been on the market for the past 3 decades. So as a result of that, I do recognize the incredible innovations that continue to be presented, and I'm very excited to talk to you about some of the innovations that we're seeing right now today. I'm going to try to also minimize giving you any opinions during the webinar, because that's not what you're here for. You're here for facts. And joining me, you can see on your screen right now, and he'll introduce himself in a couple of minutes, is Shai Mindel, the president of Babyark. You'll hear from him in a few minutes. But just to kind of get us started, um, really the car seats are very important and often overlooked. According to NHTSA, I'm going to go from the bottom first. Car seats reduce the risk of fatal injury by 71% for infants and by 54% for toddlers. And that is based on, you'll see that sometimes accompanied by when they're correctly used. That's not really true. That data comes from the way they're being used in the field right now. So it includes the misuse, and they're very effective because car seats are amazing. If they are correctly used, they're even more effective than that. According to the CDC, though, misuse rates are about 59%, and that diminishes their effectiveness. And if you look at the NDCF, the National Digital Check Form at carseatcheckform.org, they're showing an overall misuse rate of about 66%. So that's what we're trying part of what we're trying to fix as technicians during Child Passenger Safety Week, and part of what manufacturers are trying to do through new designs of their car seats. So with that said, I just want to kind of give you a mantra to think about as we talk through this. And that is that energy, when it's transferred to human tissue, that's what causes injury. And that energy can take a lot of different forms. It can be chemical energy, electrical energy, mechanical energy, thermal, nuclear, gravitational. We're going to focus, obviously, in this session, and whenever we're doing child passenger safety, on crash energy and crash force. And that's really what we're trying to solve for, is how can we control that energy? How can we manage that energy? And car seats do a great job of that. You can see on the top of your screen an early prototype for the first real car seat in 1964. And you'll notice it was rear facing. It was in the front seat. It didn't have any straps on it at all. But because of distributing the force across the child's back, the entire back, and protecting the child from the sides, it did have some value in managing that crash energy, that extreme energy. And then current and future designs are constantly coming out, and there's a diagram of one where, with computer simulations, manufacturers are able to identify where the energy is appearing in the car seat, how it's being distributed throughout the car seat, how it's being distributed throughout the child dummies or the simulated child's body. We're continuing to see better and better car seat designs that do that. But the goal is to reduce the amount of energy experienced by the child, to redistribute that, because reduced energy means reduced injury. And so that's really what they're trying to do through these designs. As we When we're thinking about the innovations and the things that are making differences in the car seat world, there are really three basic areas that that cause these improvements, that cause these car seats to become safer. And that is um, having better innovations from manufacturers mainly, where they're able to design something that either takes out misuse or that improves the way that crash energy is managed. So those innovations are fed by research. The research that is done internally by manufacturers in a lot of cases, or research that is done and publicly shared through peer-reviewed journals, or research done by government agencies, serve that innovation by manufacturers and help them to come up with new products and new designs. We also see expert recommendations that are constantly evolving. They've been evolving as long as I've been in. Like I said, I've been in for 30 years, where we've seen those recommendations, the best practices change. And they change every 5 to 10 years because we have new data, new research that's showing us what the results are today and how they could become better. And then we also have kind of a benchmark that keeps getting higher and higher and higher, and that's regulation, where every car seat that's being sold on the U.S. market has to meet all of the stringent federal regulations, and they are very stringent. And those regulations are constantly improving. In a couple of minutes, I'll talk to you about some of the new ones that we can expect as child passenger safety technicians over the next 2.5 years. But again, all of that, the regulations, recommendations, and innovations all center around research and new data. So just to give you an example of research contributing to a recommendation, there was a study that was published, an updated study that was published in 2018. And that study showed us that, first of all, the car seats are amazing in general, but it was looking at whether rear-facing or forward-facing is safer, and for what size or age of child it is safer. And what they found was, if you look at the conclusion on that page, it says non-US field data and laboratory tests support the recommendation that children be kept rear-facing for as long as possible, but the data supporting that in the U.S., the U.S. crash database field data is too limited because car seats are working so well. We don't see that comparative injury of kids that we would need. As a matter of fact, one estimate was it would take us 60 years of crash data before we were able to give specific ages or sizes of kids that are definitely safer rear facing. So in the meantime, we have to depend on the international research that we have. So what happened in 2018 is the American Academy of Pediatrics changed their recommendations from their 2011 recommendations, where they said kids are 5 times safer up to age 2. That data was no longer applicable. That research that supported that age was actually retracted because the sample size was too small. And so they changed it and just say as long as possible rear facing. The NHTSA recommendations did not have to change from 2011 because they didn't give specific ages or sizes of kids in their recommendations. So that has remained constant since 2011. But just gives you kind of an example of how research is constantly causing these recommendations to evolve, just like the products are evolving. Another example, research to regulations. Some of us on the call right now, many of us are child passenger safety technicians, and we are aware that there's going to be a new regulation requiring side impact protection, a certain type of side impact protection in car seats. And Shai will talk to you more about what Babyark is doing toward that. But when that started in 2002, NHTSA did not know what to look for. To have the best intervention for side impacts, they needed to have more data. And if you look at the letters A, B, and C, where things were lacking at the time and they needed to use an advance notice of proposed rulemaking rather than proposing actual rulemaking, they needed to know more about the crash characteristics where kids were getting hurt. They needed to know more about the test procedures and didn't even have a dummy that was appropriate for side impacts at the time. And they needed to be able to balance whether there was benefit from a cost basis to undergo the expenses to do this. So that was in 2003. Here we are 21 years later, and we're awaiting the side impact standard. But that research that they did, collecting that data, actually contributed to it. So right now, everyone on the call who's a technician was trained to know that FMVSS 213 is what regulates car seats. We have an upgrade going into effect on December 5th of this year, that is going to change FMVSS 213. And just to give you some ideas of how that's going to happen, one is that before going forward facing, the car seat is going to have to be labeled, and the instructions are going to have to state that the child is at least 26.5 pounds before going forward facing. That's the size of a 95th percentile 1-year-old. So rather than adding an age, they added a weight that's going to cover all 1-year-olds, and even a lot of 2-year-olds are going to have to stay rear facing. Another thing that they're changing is kids aren't really ready for boosters until they're at least 4 years old. So rather than using an age, they used a definitive description. So kids cannot go into booster seats until they're at least 40 pounds. Most manufacturers have done that voluntarily before this regulation goes into effect, but now there's a regulation saying all manufacturers have to put that minimum weight on their booster seats. They're also improving the registration cards, because not enough families are registering their car seats. And if you don't register your car seat, you're not going to be notified in the event of a recall. So they're changing it, giving manufacturers more flexibility and updating it. Instead of the 1992 business reply mail card that's been used up until now, they're allowing the use of a QR code, which is today. They're allowing use of phone numbers, since we all depend on our smartphones for everything. So being able to communicate through that cell phone is going to be important. We're also adding a new regulation, and that's the side impact that I mentioned earlier, where the advance notice of proposed rulemaking fed toward this. And what that's going to include, this goes into effect June 30th of 2025. It covers car seats that go up to 40 pounds or 43.5 inches. So it's not covering up to 65 pounds yet, or booster seats yet, just because we don't have a dummy to measure the forces in a side impact yet that's bigger than a 3-year-old. But what we do have is a new sliding structure. You can see an image of it on the screen. You can also see that it has, it's got an offset to it. It's got a 10-degree offset to it. And that's to simulate that a vehicle is moving forward, crossing an intersection, and then struck on the side. So multiple forces acting at once. And it's got a door panel, a simulated foam door panel that represents the intrusion into the passenger compartment. The test protocol represents a vehicle-to-vehicle side impact, where one vehicle is moving forward, the other vehicle strikes it on the side. And they put in rules. If they're using the crabby 12-month-old dummy, that's the same dummy that's used to test airbags and used for car seats right now, is that you can't have head contact with the door, with that simulated door panel, for that rear-facing 1-year-old. And for the 3-year-old, the Q3S dummy, the last bullet there, measures the head injuries of that child through a calculation called Head Injury Criterion 15, HIC 15, and also the chest deflection to measure the likelihood of torso injury for that child, which is another area we would see because of the intruding door. So that's coming again in June of 2025. All manufacturers will have to meet that with all car seats made on or after that date. It is not retroactive. And then in 2026, December 5th of 2026, so about 2 years from now, we're going to see a new frontal impact standard. And really what NHTSA has done is they've changed the bench, and you can see an image of it on your screen. The current bench where car seats are being tested is based on a 1974 Malibu. We're not seeing car seats in 1974 Malibus any longer. So what they've done is they've looked at current vehicles, and the current seat back and seat slope angles are one thing they looked at. They found that current vehicles have thinner cushions and denser foam instead of really fluffy cushions like they used to have in the 1970s. They're also going to be testing with a lap and shoulder belt instead of testing with just a lap belt, like they have been up until now. There are going to be new weight rating guidelines, and I'm going to add one more in. That I already told you about, the 26.5 pound minimum for forward facing and the 40 pound minimum for booster seats. But they're also adding in that a rear-facing only seat or an infant seat that's rated below 30 pounds, so that's the maximum weight allowed by that rear-facing infant seat. It has to be tested with the crabby 12-month-old only. If they want to rate higher than that, so a 35-pound infant seat or a 40-pound infant seat, which we as technicians have seen, then they also have to test with a 3-year-old dummy. Most manufacturers that I've interacted with have decided they're going to drop their infant seat weight, their maximum infant seat weight, to about 30 pounds instead of trying to cram a 3-year-old into an infant seat. And then another quick example is research to innovation. And this is one study of many, many that we're constantly looking at that looked at rotation reduction features. And those could be load legs that reduce the amount of rotation of a car seat, or they could be other features. And actually, my next slide gives us an example. So it could be load legs to stop the car seat from rotating or control that rotation. It could be rear-facing tethering. And we've seen a couple of models that still that are allowing that, innovative models that are allowing rear tethering for that same purpose to stop it from rotating. European shoulder belt routing is another way that it's being done, where the shoulder belt is wrapped around the back of the shell. And now a new study that's going to be published in the next month shows us that having the car seat shell in contact with the vehicle seat in front of it, so the front seat usually, has the same effect as a load leg. And so it can also be very useful in controlling rotation and distributing forces in a better way for child injury. Another set of research, just to highlight really quickly, is the forward motion of the child seat. We've got lots of research showing that tethers improve the ride down with the vehicle and improve head excursion, reduce head excursion that the child experiences. We're also starting to see, we've got a couple of models right now that allow load legs to be used forward facing, and Shai will talk to you about that from his perspective in a couple of minutes, that has a similar effect to tethers, but sometimes in an improved way for certain designs. Shoulder belt installation integration, where I mentioned to you they're going to be testing with lap and shoulder belts both, integrating that shoulder belt into the belt path. So that the shoulder belt is high on the car seat, can make it so that has almost a tethering effect. Rigid lower anchors means no motion of the car seat at all, essentially. So very good ride down with the vehicle, and even some of the amplified force installation features, some of the things that help us in car seat designs that help us to get a tight installation, especially with a seatbelt. Can reduce forward motion. And then ease of use. A correctly used car seat is a safer car seat. So making it easier for parents by using color coding. So rear facing on your screen, rear facing and forward facing have different color codes. Device assisted installation, car seats that help you to make it tight without exerting more force. Lower anchor designs that make it easier to attach or detach the car seat. Is also an improvement. And then improved instructions, and those could be interactive instructions or more graphic instructions using pictograms. And just real quick, one of the things that we need to understand as technicians, this is from the National Standardized Course. We know the mantra, the best car seat is the one that fits your kid, fits your car, and you're going to use it right. But we also have to be respectful of is that not all car seats are created equally. And so budget and lifestyle, if you look at the very bottom of the page, is also included in the curriculum. And sometimes car seats that have the more advanced features cost more. And sometimes your lifestyle requires a certain type of car seat as well. Just to put that in perspective, all car seats meet federal motor vehicle safety standards. Some of them go way beyond those stringent standards and make their car seats far safer than is required by standard. There are some good resources for the parents on this call and for the techs on this call. Healthychildren.org is an American Academy of Pediatrics site. There's a QR code on your screen for that. And that lists every car seat that is currently available or will be available soon, and some of the characteristics of it, like how far it can be used, how long it can be used rear facing, how long it can be used forward facing, and the price of it and some of the other characteristics, like is there a load leg? Is there rear facing tethering? And then the NHTSA ease of use ratings, a brand new study done by Dr. Michelle Macy and her team in Illinois, has shown that the car seats that are getting a higher ease of use rating are actually seeing in some areas, limited areas, but in some areas, reduced misuse levels. So they are more correctly used. So there is definitely an association with the NHTSA ease of use ratings. There's a QR code for that on your screen as well. And the bottom line is, regardless of what car seat you have, which one you select and which features it has, you have to use it right. And that includes, again, from the standardized curriculum, what we learned as technicians, selecting the right car seat, facing it the right direction for the child and for the car seat's design, locating it in a place that's appropriate for crash protection. So it could be the rear middle back. It could be definitely the rear seat away from airbags. The harness has to be adjusted to fit the child properly according to the instructions. Car seats are designed and tested a certain way, and that's what the instructions reflect. And also installation appropriate the way the car seat manufacturer said to do it, and also the way the vehicle manufacturer said to do it. So that's the key, regardless of what car seat you're using. So with that, I'm going to turn it over to Shai, the president of Babyark, and let him talk to you about how they're applying these concepts that I just talked about.
All right, thank you, Joe. Thank you very much. So before diving into the presentation, so I'm Shai Mindel. I'm the CEO of Babyark. I'm 45 years old. I have 3 kids. My background is I'm an aeronautical engineer. I actually started another company that designs and manufactures energy absorbing seats for military application, aviation applications. And based on that background, we thought, why not take the technology that we invented for aviation application, for example, and put that in car seats. So the purpose was to simplify the installation, to have a better ease of use, to implement some new technologies into the protection of the kid. And I'll try to elaborate a little bit on what we're trying to do here on the car seat design. So we are focusing on the Babyark car seat, on the energy absorption, about the materials and structure that support that, about installation features that helps you minimize misuse, and as Joe mentioned, correctly used car seat is a safer car seat because it's actually used as tested, so that's super important, and how technology today can help us with everything, with the usage, I would say, of the car. So I want to show you a few things. As I mentioned, I would say we specialize in energy absorption. We invented a new energy absorption technology, and I want to show you how it works. So we implement the technology in the car seat. On the top, you can see a video. You can see how this is approximately 220 pounds weight. So you can see how, I'll show it again, how the energy absorbing element is extended. And you can see how it kind of reduces the speed and kind of have a softer absorption of the weight. So that's what we're implementing in the car seat itself. You can see during an accident, there is a base in the seat, and we'll discuss that. So the base includes the energy absorbing element. It's the same element you've seen before, and it absorbs the energy during a crash. You can think that of a soft brake and a hard brake of a car, or a crumple zone. Basically, you want to divert the energy to different elements around the kid. The amount of energy in every crash is finite. So if you can absorb the energy by other elements, it's going to finally reduce the forces transferred to the kid. So this is the main element that is responsible for the reduction of energy or forces that are transferred to the kid in a frontal impact. Now, the way that we do it is basically the technology allows us to optimize the performance of the energy absorbing element. Again, just like a crumple zone in a car, the crumple zone is designed for certain forces, for the weight of for the mass of the vehicle, and I would say the adults that we want to protect inside usually. So what we wanted to do is to optimize an energy absorbing element that can fit kids between newborns to 6 years old. And what I'm showing here is basically we have a lot of control of how the energy absorbing element behaves, and we can do that by simulation, by testing, and this is what we've tried to do to optimize the performance for newborns to 6 years old. You can see here that Joe mentioned, so the criteria, according to the regulation, is approximately the HIC level of 1,000, not approximately, exactly, of a HIC level of 1,000, and the lower it is, the better. So what we're showing here is that basically we are approximately 75% lower than the recommendation, the requirement by the regulation. So the lower it is, the better. And what we want to do is, again, to find an optimized place for kids between 1 year old to 6 years old. In the design, we try to provide better results for smaller kids because they're more vulnerable. Head injury is more more predominant with kids, so that's what we try to do with smaller kids. Okay. Another aspect is side impact protection. It's real life. I mean, this is one of the more common accidents that we can see. Regulation addresses that, and I think it's super important. And what we try to do is try to kind of biomimic a very good solution. What you see here is the internal structure of a woodpecker. A woodpecker, I won't go into a lot of details, but has an amazing brain protection mechanism that diverts a lot of the forces around the brain. You have a spongy bone that distributes the forces, reduces the forces on the woodpecker brains, and basically woodpeckers can peck the tree thousands of times a day with no hand injury. If you think of football players, you know that there are internal concussion, and that's something we wanted to implement in the car seat. I'll just show very briefly how it looks. So during a side impact, we have an energy absorbing element. It's kind of a wing that's you can think of the beak, but you can see a wing that is protruding to the side of the door. Okay, and during an accident that absorbs the energy and diverts the forces around the kid and to the side, and reduces the amount of energy that are transferred to the child. There is more to that, but this is kind of to show a small demonstration of how it works. Okay, now it's very important for the seat to be correctly installed. It's very important that the forces are going to be diverted or to the energy absorbing element in a controlled manner. So what we wanted to do is to rely on proven methods to connect the car seat to the car. We wanted to isolate the car seat as much as possible from the car itself, because if we're relying on vehicle cushions that can change from time to time, okay, from manufacturer to manufacturer, so we're not going to have a constant performance, so with a redundant performance in each crash. So what we're using is elements that, again, are proven to improve safety. We're using as a support leg, as an anti-rotational element. We have rigid lower anchors combined with a seat belt for redundancy, and anti-rebound bar that improves stability and prevents rotation on the rebound effect or rear impact. The redundant seat belt can be used. It's not common, but it's used in several car seats. The Clark Funks allows that. The Nuna Pipa and us allows that kind of installation. The redundant seat belt is Joe. You want to elaborate a little on that?
Last being introduced, there was a international standards organization working group for latch. And it was a group of manufacturers that were asked, is there going to be a problem with using the seatbelt and latch together? And the three answers they came up with, the three concerns that they came up with at that time, was that the possibility of using latch hardware and having it contact the vehicle belt and buckle could cause the webbing to fray or weaken over time if they're rubbing against each other. The possibility that the vehicle belt and latch anchorages might not be collinear, they might be coming from different angles, which could change the performance of the car seat. Or the possibility that using both of them would make the installation too stiff, so that it was not going to perform the way it was intended to perform. So yeah, those were their concerns at the time. And Shai will talk to you about why that doesn't apply here.
So none of these factors apply to Babyark. It was tested for a redundant installation. We have a very clear tunnel for the belt. There is no way for for interference between the rigid lower anchors and the belt. So it actually the way the car seat is designed, and the car seat need to be designed in order to be installed like that. It has no interference, and it's actually adds safety. So this is why we want the redundant installation. Now, what we try to do in Babyark is try to implement the best practices of installation, energy absorption, in order to kind of provide a safer solution, or as safe as we can. So we are using rigid low anchors. We are using support leg. The support leg is used instead of a top tether, and I'll show that in a crash test, but the seat does have a top tether because we must have that in order to comply with the regulation. So you can install that with a top tether or with a support leg. Both of them are good. Our test results shows that support leg provides better results, and I'll show you why. High rev facing limits, rev facing installation kind of distribute the forces better on the child's back, so it's recommended. We have same installation for rear facing and forward facing. The base is the same. I'll elaborate on that. It's a smart seat. It has 14 sensors that guides you through the installation process in order to minimize misuse. And we're trying to use the best practices regarding the instruction from NHTSA about the weight and etc. So the rigid low anchors provide stability. It's a steel-to-steel connection to the car. And what's happened during a crash? We have the same forces transferred to the energy absorbing element in each crash. So when you have a webbing, so the webbing itself extend a little bit. So the tension is different, so it's going to extend differently. So it's going to affect the crash performance, and it's kind of depending on the user who installs the seat. So we try to minimize that. It's going to be very redundant, and that's why we like the rigid lower anchors and the way it's connected to the vehicle. Okay. Support leg. Support leg is another anti-rotational element. It can be used instead of a top tether. We have a certain advantage in the car seat design because it allows better performance of the energy absorbing element, and I'll explain. But it also allows an easier installation because top tether is different. The connection itself is different from car to car. You need to pull it. You need to apply the right force so the belt will be tight. Sometimes it's located in the trunk, sometimes located just behind the seat. And we can see that people sometimes do not install it correctly. The way that the support leg is designed, it kind of fall into place almost automatically. You will see the installation video. So it's basically almost impossible to install the seat without the support leg installed. So that again minimizes usage, minimizes the misuse, and we make sure that the seat is installed in the car as tested, so it improves the performance and the behavior during crash. Rear facing, I think it's been discussed a lot. The forces are distributed on the back instead of just transferring all the forces to the head. It's much more important for young kids, and this is why the regulation kind of requires that. For young kids, the neck muscles are very weak. The head mass is almost 25% of the body mass. So you want to protect smaller kids. I think it's also beneficial for older kids, but it's critical for smaller kids. One of the things that we try to design is to minimize the complexity of the car seat design. Now we know that sometimes you have you need to install the car seat differently. The installation install it differently with forward facing or differently on the rear facing. You need to go to the manual. Sometimes it's 2 years since you installed it. it can be tricky sometimes, and it's prone to misuse. So what we've designed is we've designed the seat in a manner that you install the base. Okay, the base is constant. You can see that in the GIF file that you see kind of jumping from forward to rear facing. And you can see basically that the support, like the anti-rebound bar, is serving both front facing and rear facing. And basically the seat just clicks in and out. There is almost no way to make a mistake. You'll get a notification. You cannot place the child in the seat if the seat is not properly connected to the base. So again, it's minimizes misuse. And you don't need to read the manual. You don't need to kind of, even if you haven't installed the car seat for quite a long time, it's quite easy to put it back forward facing or rear facing. And we'll discuss the benefits of the app and how it helps us. Another benefits that the fact that we have a separate base and a seat that it provides different usage. Joe mentioned, for example, the different families have different lifestyle. Okay, so for example, if you don't need, if you have a caregiver, you have a grandmother or grandfather that takes the seat as a kid sometimes, you don't need a full seat that you need to put in the trunk, then you put it back on the seat. You're not sure if it's correctly installed, so you can just take another base, put it in the other car, and just switch the seat. The seat again just clicks in, minimizes misuse. You have the app in one of the version. You have an app or basically the lights to make sure that the seat is correctly installed, so you know it's safe. So again, it kind of minimizes the hassle. We know that the car seats are sometimes difficult to install. That's why you need professionals. That's why you have your all CPSTs. So we're trying to make it more approachable to a lot of people to make sure that the seats are correctly installed. We can see technology all around us. Okay, there are sensors, we have smart rings, we have smart cribs to help you sleep, we have monitors. And I think that until recently, and we see it more often, technology hasn't been implemented in car seats enough. And I think there is a lot of benefits using sensor, using technology in order to improve safety, improve awareness, and simplify the installation. So the seat is designed, all the technology, I would say the electronics are only in the base. There is no electricity, no electronics in the seat itself, okay? Having said that, the base includes 14 sensors that monitor each and every aspect of the installation and of the usage, and we can alert of different issues that might arise that are related to safety. For example, forgotten child, we know if the child is buckled, we know we can identify child presence. So if, God forbid, someone leaves the child unattended, so we can give an alert. We can give not only installation assist kind of assurance, also assistance if something goes, if you're not sure what to do. So the app, and I'll show you that in a few seconds, the app actually can identify the stage and the installation you're at, and then they can guide you through the next steps. It can give you ride info if you want to check that the kid has been picked up from the kindergarten, driving safely home and buckled, so you can see that as well. And of course, like we have in adults, if you start driving and you're not buckled, you'll hear an alert in the car. It's the same with the car seat. Okay, so I want to show you the installation process. The app is just for guidance and to help you. So the seat can be perfectly installed without the app or without any technology. I'll show you just a second. I'll show you a quick installation video just for the purpose of the video, which is kind of 20% faster than in usual, just to kind of because of the time. And you can see the base is installed first. We are connecting the lower anchors, the belt. We are locking the belt. Okay, you will see that we are guiding that also. Anti-rebound bar and the front support leg. That's it. The base is installed, and then basically you heard the click. Only now the kid can sit inside. So this is the installation process. Quite straightforward, and it's I think it's intuitive. Okay, we have the rigid lower anchors, we have the support leg, and the anti-rebound bar. All of them are kind of performing in forward-facing and rear-facing installation. Now the app is here to support, and I'll show you. Just a second. This is a installation process with the app, okay? And the app is here to guide you in the process. So the installation is exactly the same.
Pick up the base by the handle and let the stabilizing load leg fall into its locked position.
So it gives you the instructions
Awesome. Secure the vehicle seat with one
and gives you
push button.
confirmation after each step.
Awesome. Root through the belt path and buckle the seat belt.
Now, since it's connected to an external element, I would say the buckle. So you need to manually approve that you've buckled that.
Fantastic. Make sure the seat belt is tightened and locked.
So we're going through the process of correct installation.
Fantastic. Press button to activate the anti-rebound bar. Brilliant. Pull and extend the lower part of the leg to secure to vehicle's floor. Great. Place the seat over the base in a rear-facing position.
Now, if you put the child age in the app, so we'll be able to instruct if it's should be facing rear facing or forward facing. If the child is too young and you're putting it forward facing, we will alert you that this is not the correct installation. Okay. So the app is here to assist, to guide you if you're not sure what to do. So it will give you the next steps. It will give you a confirmation that everything is correct. Because sometimes, I mean, when you install a car seat, I know that's a problem I faced. Even if I installed it correctly, I didn't have the assurance that I've done it right. So basically, if we have an app or you have the sensor saying, guys, you've done all the steps, the seat is correctly installed, it kind of takes some of the tension away or the anxiety. Having said that, we are not, this is our recommended installation method because this is the best performing installation method in a crash test, and I'll show it in a second. But we are allowing 3 other installation methods. We're facing with lower anchors only up to a certain weight. We're facing with the vehicle seatbelt only, as required by regulation, and forward facing with vehicle seatbelt and top tether. Okay, so all of those are allowed. So basically, you can install the seat in 4 different manners. We are again recommending the one that has a lower anchor, support leg, and down ribbon bar. Now I want to show you why we're recommending the installation method with the lower anchors and support leg. I'll start with the crash video on the left. So on the crash video, both of them are 6-year-old kids. Okay, so you can see that the base. Okay, I'll just stop a few times just to kind of guide you through. So you can see the base is very stable and it's kind of floating above the cushion. So we don't care if it's a Malibu 74 or if it's a new Tesla Y. So we are floating above that. All the forces and the base is designed for that are kind of maintained, I would say, inside the base. Now, if you look on the rear of the base, you can see how it kind of moves forward. The white part separates from you see how it separates from the black part. And this is where the energy absorbing element comes into play. We have 4 inches of movement it elongates, it extends it downright and absorbs the energy. So the forces transferred to the kid are lower. If you're looking, for example, on a top tether and on a belt installation, so you can see that the belt stops the seat in place. Okay, so it doesn't allow that extra movement that we want to absorb the energy. And again, you can think of that of a soft brake or hard brake in a car. When you do a soft brake, it takes a little bit more, it takes more, longer distance, but there are lower forces on your body. If you have a hard brake, so basically have higher forces on your body, but it stops momentarily. So the more we can extend the downride, it's better. We are limited in how much we can do that because of I would say, limited space we have in the vehicle. So we are allowing only 4 inches. Another aspect where technology comes into play, the Hot Cars Act. Joe, I think we can hear you.
Can you hear me?
Yeah, now, yes.
Yeah. According to Kids and Cars, which is a leading heat stroke prevention organization, as well as noheatstroke.org, which is a website that the NHTSA funds, we're seeing too many kids. One is too many. who are being killed in hot cars, who are dying in hot cars. At least 7,500 kids have been left alone in hot cars, or have accessed the vehicle on their own, unoccupied cars, since from 1998 to 2020. Of those, we've lost over 1,000 of those kids. We've lost 32 so far this year. So the Hot Cars Act was incorporated into a larger bill, and was passed in 2021, signed by President Biden in 2021, which would require vehicle manufacturers to have an alert system for people to remind them if they have children in the car to check the rear seat, using different methods. That method hasn't been determined yet. NHTSA had until 2023, November of 2023, according to Congress, to implement that standard. But the research is still continuing, so it's not ready yet. But some car seat manufacturers are stepping in to help to prevent heat stroke injuries as well. And Shai can talk to you a little bit about that.
Yes, so the way that the seat is designed is you have a sensor that can detect child presence, and if the child is buckled. One of them is enough to, I would say, initiate the process. Now, if the car seat or the base is connected to your phone, to the app, and if you're stepping away from the car while the last status that we had on the seat, that the child is either buckled or seated, you will get an alert on the phone. This is I would say simplifying the explanation. So as long as you have the phone with you and the app is running in the background, it's enough. It just kind of communicates with the base and will alert if you're stepping away from the car seat. And just an example of how, again, technology can help us. So, for example, this is a feature that we're going to have in the future. But for example, different states have different laws. Okay, some of them allow unto 1 year old, and some of them allow up to 2 years old rear facing, for example. So if we have if you have an app, we know the age of your kid. So we can say, for example, you drove from a state that allows from 1 year old rear facing to 2 years old, please make sure in that state you need to make sure that your child is rear facing as well. So just an example of what can be done in the future. And there are other aspects. We can sensor to make sure that the child is relaxed or is asleep, but this is more down the road. I mean, technology can help us a lot in different aspects.
Yeah, we questions, Shai. Thank you. But several have come in. We'll spend about the next 10 minutes going through those, and then Stephanie's going to talk to us a little bit more about CEUs and what we need to do as technicians to get those. One that I already answered in text was where is the study coming from that's going to show that touching the seat in front is like using a load leg. And my answer was, I believe that the extensive study showing that the nearness of a rear-facing shell to the forward vehicle seat controls rotation for injury reduction benefit, and that's going to be published in the Traffic Injury Prevention Journal sometime, I believe, in the next month. Shai, we've got a bunch of questions for you too. With a majority of family vehicles being something like the Dodge Caravan or other vans with stow-and-go seating, is the Babyark permitted to be used without the load leg? This would make this incompatible in many minivans as well as some trucks that have floor storage. So can we still use it without the load?
The load leg is not allowed to be used if you have a compartment on the floor. The floor needs to be very rigid to kind of withstand the forces in the crash. In that case, you can fold the leg under the seat, as you've seen in the crash test. You can connect it with a seal belt, only a top tether, and it can be just used just that way. So yes, it's possible.
Okay, thank you. And does the Babyark seat allow installation with both the seatbelt and latch? I think you answered that. And then when it's installed with both, is latch or the lower anchors the primary restraint, or is the vehicle seatbelt the primary restraint?
It's works in series. The primary restraint is the lower anchors. If for some reason the forces are too high, so then the belt comes into play. I have to say that We've never seen that happen, but it's designed in a redundant way. It's kind of working in two steps. One is kind of covering on the other.
Okay. Thank you. And Christina asks, how is the base powered?
So we have a battery, like a finger battery approximately. It can be charged with a USB cable, just like you charge a phone. You need to charge it approximately 2 or 3 hours every 3 or 4 weeks. So you can do it while driving, when the child is in the seat or not in the seat. It's not an issue. There is very little energy consumption. We're using very little amount of energy.
Okay. Christina also asks, does the front of the base have to have full contact with the vehicle seat? It looked like it got raised up when the support leg was extended.
Yeah, the 80-20 rules do not apply in Babyark. It's kind of floating above the seat. It's by design. The base itself is designed in a very rigid manner. There are steel bars inside connected to the aluminum leg. So basically, all the forces are transferred to the base. We are not relying on the vehicle structure, except the floor and the lower anchors. But I mean, the structure itself of the base is strong enough to withstand the forces. So it's kind of floating above the seat, and this is by intention.
Okay. Thanks. Does the app accommodate different seatbelt types, like an emergency locking retractor versus a switchable retractor?
Currently, we're just kind of instructing you how to lock that. I'm not sure if most people know if it's a LELR or switchable, so we're just kind of instructing you how to pull that and then to make sure that you pull it back. I think the performance, I mean, practically it's the same. It's the same way, but so we're just kind of showing you in the video how to do that and to make sure you do not forget that step.
Yep. Thanks. The support leg in the forward-facing video doesn't look like it's at a 90-degree angle. Is that an important element to consider in the installation?
It's not 90. Okay, sorry. Continue.
The continuation of it is, does the sensor tell you whether the load leg is at the correct angle?
Yeah, so it's not in a 90 degrees angle. It's a little bit more than 90 degrees because you have a 15 degrees in some car seats, so we're compensating on that. There is only one correct angle. There is a kind of inside, there is a slot. The leg goes inside, so it cannot go, it's either can be installed correctly or not installed at all. So it's not 90 degrees. You cannot put it in any other angle. So basically, the design guides you to the correct location. And the sensor is going to let you know if something is wrong, but basically there is an OR notification if you don't have a sensor, like a kind of a plastic notification, but there is only one way to install it in the correct location.
Okay. Thank you. And thank you for those great questions, Christina. Audrey asks, does correct installation include deploying the side impact wing next to the door? Audrey didn't see that in the examples.
So as I mentioned, there are no sensor electricity in the seat. So we do not know if you installed it correctly. In the installation process, you have another step of adjustments, I would say, to make sure that the headrest is in the correct location, to make sure the reclining is in the correct location, and also the side wing is open. So we're kind of guiding you through the process. But in that case, we don't have sensors monitoring that. So we just explain you how to do it right. So this is not part of I would say the process that is controlled, guided by technology. This is just another process that you have in the app that with videos and explanations.
Great. Thanks for that question, Audrey. Margaret asks, how do you see the app being utilized in regards to car seat checks? If we have a caregiver with this seat, should we walk through it with the caregiver and the app?
I'm not sure I understand the question, Joe. Can you help me?
I'll kind of rephrase it a little bit. If a Babyark is brought to a car seat check, then we as technicians, how should we interact with it? Should we use the app and walk the caregiver through the process with the app, or should we do it on our own?
It's up to you, I would say. Okay, if you're familiar with the seat, you're familiar with installation, you know how to install that. You don't need the app for guidance. The seat, the base itself will also give you the green lights. Have you seen that making sure that the seat is correctly installed? If you can place a child in the seat, it means it's correctly installed. Having said all that, it can be kind of just as a to mark a V on that. If you can just go to the app will tell you everything is correctly installed, just to make sure that nothing is forgotten. You didn't forget the belt, for example, or something like that. So that can be beneficial. It's not mandatory. The app is here to help. If you know you've done it right, you get all the signals from the base, then you don't need it. But sometimes it's nice just to get the confirmation.
Great, thank you. Margaret also asks, as a follow-up question to that, if there's a problem with the installation that the parent did based on the app, is there an opportunity to connect a child passenger safety technician on your team to help problem solve?
So technically, it's possible to have a chat in the app. It's not something that it's already embedded with something we're thinking of, and we are going to add some kind of a support. If everything fails, you're still not sure if everything installed, we have a professional to guide you through the process to make sure that you're going to install the seat correctly. It's still not embedded in the app, but it's going to be in the future.
Okay. Emma asks, is it not possible to use rigid latch, a seatbelt, and a top tether? And am I understanding that there's no option to use the load leg and the top tether? And her reason for asking that is, does this mean Babyark will not be coming to Canada where a top tether is required forward facing?
So we haven't tested that configuration. This is something we're discussing. I mean, lower anchors, belt, and top tether. So we're not recommending that until we're going to complete the testing. This is something on our, I would say, on our to-do list to make sure that we can install the seat in that manner. There are compromises to be made with that installation because the top tether is going to kind of connect to the seat, so it will not allow the forward movements that we've seen with kind of optimizing the performance of the energy absorbing element. So the answer is no, it cannot be used right now. We're testing that. Once it allowed, we will instruct and publish that.
Thanks. And Julie first makes a comment that she loves the technology and the user feedback features, but then she asks, considering the built-in forward movement of about 4 inches, she thinks she said, is there any recommendation for spacing between the forward-facing child's legs and the front row seat? Any concern of the legs getting pinned between the base and the front row as it deforms forward, or does the base move between the legs?
Base move between the legs. The leg stays in place. The base kind of floats above that and moves forward. We are recommending to leave space in front of the seat to kind of allow that movement. For smaller kids, you need less movement. We're recommending up to 3 inches rear facing, and forward facing up to 4 inches because usually the kids are heavier. Because of the I would say nobody sits in a 90 degrees in the seat. You have like a 95, 97 degrees angle for ergonomic purposes. So the lower part of I would say, passenger seat of the driver's seat I would say, we have more distance from the base. So that's what allows the movement. If you've seen in the crash test, we are complying with all the space claims that are required by the regulation to make sure that it's in the right space claim.
I'm going to ask
I
a
hope-
follow-up, Shai. I think she's talking about the child's legs. So is it possible because the car seat is moving forward and a forward-facing child riding in it, is it possible for their legs to contact and become pinned between the forward vehicle seat and the base for injury?
I don't think so. Okay, I don't think, basically, we're not taking more space than allowed by regulation. We have seen that, for example, because the belt there is tension in the belt, it's elongating as well. So even a belt that is very tight, and it doesn't really matter how much force you put that in the doll to try to put tension on the belt, the forces in the crash were so high that it's going to create some tension. So and I can show that. I don't have that video here, but I can show that I can discuss that and show that basically we're not taking more space claims than other seats during a crash. It's a controlled motion with the energy absorbing element instead of kind of a certain movement that you have anyway because of the elongation of the belt. Did I answer that?
I think so. And Julie knows you, so she can certainly ask you on an individual basis, if not.
I will be glad to show you crash videos and show you that.
Yeah, it is. I think we're at time. So I think Shai and I will stay on and continue answering questions if anybody wants to stay on. But let me hand it off to Stephanie for a minute so that she can complete the recording and tell you about your CEUs. Stephanie?
Yeah, I appreciate that. Thank you. And it was a very great webinar, and we appreciate both of your time. So as Joe said, they'll stay on. And if you'd like to stay on, that would be great.